now we're going to dig down a little bit deeper. We're going to go into SysML v2 itself, just to get a sense. How many of you are, relatively intimate with v2? And how many of you are pretty new to v2? So, and how many of you are sort of in between? All right. A lot of you didn't raise your hand, so I don't know what you are. Okay. All right. This is more or less geared primarily to some of the new folks, but hopefully some of it will be a repeat, but you'll recognize it for those of you who've been involved. So let me just go through. I've got a couple of slides on MBSE background. They're just standard slides that I show, kind of a level setting slides. I've used them for forever. And then I've got a slide on the status of SysML v2. And then I'll go through a brief overview of SysML v2, kind of highlight some of the differences with v1. And then I want to say a few words about our community, because this is a really important part of this whole effort. This is a community that we're trying to build. And then I'm going to have Vince Molnar come up and just share, a couple of slides that he has on one of our working group activities, just as an example. And then I'll wrap up. So that's what I'm going to talk to. So let me go into the background. And again, these are my two kind of level setting slides. And so if you've seen it, I apologize, but I think they're important so that we're all talking the same thing. This is a classic block diagram. And how many of you have seen block diagrams that look like this? Okay, every block diagram I'd ever seen looked like this. This is a classic system engineering block diagram. I think it was done in Visio. I pulled it off the web, so whoever wrote it, if you happen to be in here, thank you. And but it's a good block diagram. When you look at it, it's got a lot of domain knowledge embedded in it. But it's not very precise. And so the person who put it together, they know exactly what they're doing and what they're thinking, but it's not something realistically, it has some limitations when it comes to using it as an artifact to design to. And so, for example, you can't really tell the component hierarchy here. There are things that look like they might be components and other things that are nested within other things that you might think are parts of that component. They may or may not be. The interfaces, you see lines with arrows on them, and you ask yourself if they're interfaces, and they're just not specific enough to, clearly not to design to. You couldn't go write an ICD from this, for example. You can't actually differentiate very easily a function, what something does, versus a component, which is what it is. They're kind of munged together in the diagram. And things, we call them successions, but just basically like control flow. Something happens after something else. So you see a line with an arrowhead. Does that mean something happened after that? Or is it a connection with, like an interface? You can't really tell. And so bottom line is, it's great content, but there's a lot of obvious ambiguity. And this is kind of what motivates MBSE. Is this classic, really good, system engineering, but it has these limitations. The other thing about this diagram is it's disconnected from other views. So if you had a particular view of, reliability block diagram or something is completely disconnected, or a functional flow, or a this or that, it's a standalone diagram. It's not connected. And, it lacks traceability, for example, to requirements. So if I have a requirement change and I want to see the impact on something on this diagram, there's really no effective way to establish that traceability, right? Certainly not with any granularity that you can maintain. So those are some of the challenges. And I just think from my perspective, this is kind of why I started down the MBSE, because I used to generate these diagrams. This is exactly what I would do. I tried to be really careful with them, but they still kind of look like this. So some of them were really big. They were wall size, but they look like that. and they suffered from the same limitations. So we're really trying to fix that. That's one of the foundational things. And this old slide, Steve will recognize it from JPL, goes way back when. But when we talk about MBSE, it's an approach where the information about the system is captured in this thing we call system model. And people use the term in various ways, but system model is basically capturing all that information that you typically capture in various document-based artifacts. And you want to treat that model with that data as the source of your information, you know, and manage it throughout the life cycle. That's what you'd like to do. So that's the notion of MBSE. You capture this information in a model that's maintained throughout the life cycle. Very simple concept. And you contrast that with capturing this information, a bunch of disconnected artifacts. You've all seen that, you know, model-based, or not document-based artifacts like PowerPoint, like the Visio diagram you just saw, like Excel. It's all over the place. It's pretty obvious why we're trying to do this. So again, this little figure comes from many years ago from JPL, but they just show a bunch of stakeholders here communicating via document-based artifacts of various kinds. And that's sort of classic SE. And they said, let's kind of move to a model-based approach where we get this information in a model and we share it and we're all working from the same data and it's more precise and the like. That's a basic level setting for what we're trying to do with MBSE. Now, there's many other aspects over the years. The value of MBSE can be recast in addition to this. There's all kinds of things we can do with automation and productivity and reasoning, and there's all kinds of places we can go with this, but this to me is still at the core of what we're trying to accomplish. So, little background. Okay, now, where are we with SysML? So, we started the RFP, I hate to say it, but 7.25 years ago. The RFP was issued through the OMG on December 7th, good date, December 7th of 2017. So it's been a while. And at that meeting on December 7th, is Ed here? Well, I guess he stepped out. But wherever it was, I don't remember, I think it might have been, where was it? Was San Diego? Okay, so at that meeting, we kicked off the SysML v2 submission team. So the RFP got issued, we were ready to go. We had done a lot of pre-work and we kicked off the submission team. We called it the SST, the SysML v2 submission team. That group had tons of participation from it grew over time. We had, towards the end, I think there had been as many as 85 different organizations that had participated at various levels, some very light, some very heavy involvement. And, but at any rate, that resulted in the SysML v2 beta spec being submitted and approved to the OMG, and it was approved back in June of 2023. So we're in, where are we? We're in almost April, so it's a year and 3/4 ago. It was approved as a beta spec. And from that point forward, it went into what was called, the OMG refers to it as a finalization phase. And that's where you take that spec and you really work out any of the bugs. You give a chance for vendors to begin their implementations of the specification, and you start to identify surface issues, and you kind of do a cleanup. Well, that's what we've been doing for the last year and 3/4. And the final specs were just submitted last week to the OMG. So now they are in the OMG's hands. So yeah, yay, 7 and whatever years later. There's Ed. He worked on it. He'll be talking in a few minutes. But at any rate, they were submitted for final adoption last week. And now it starts the architecture review board process. And so they'll be reviewing it, commenting on it. We'll probably have to make some minor I suspect some updates. And then we'll resubmit, and then it will hopefully get voted on and proceed through the process. So our schedule as of right now is the planned adoption is for June, which in and around our next meeting, if all goes well, unless there's some huge surprise. We don't expect that, but never know. And then the formal publication of the final adopted spec Takes another period of time. It goes into a queue and it takes a while. So probably September-ish of this year, we should have the final spec published. But for all practical purposes, once the AB approves it, I mean, I think we generally have high confidence that we're there. And that actually we're expecting in another, hopefully a month from now, because they were just submitted to the AB. So that's basically where we are. And what I want to say is, as I mentioned, we've been in the finalization phase. The tool vendors have been working like crazy. Those folks that are sitting outside there, they've been working like crazy to implement the spec. And it's there's just a lot of fantastic work. Some of them are authoring tools where you model, in their tool, Dassaults and IBMs and et cetera, and PTCs and the like. And some are analysis related tools, and some are visualization type tools. And, there's a whole range. Great. So we anticipate both commercial and open source tools being available this year. Some are actually on the market now. And the last bullet here, just to make note, is we're not done. We're clearly not done. This is a beginning. So this 7.25 years, good start, but now the work begins, and we really have to sort out and work across the community to establish good practice with SysML v2 and how to use it, how to integrate it across the digital engineering ecosystem, all the good system engineering stuff. Now we're in a position where we can start really advancing this practice. And every single one of you can play a role if you so choose. And so we'd like to leave you with that simple message. I'm going to go through these slides fairly quickly because let me just check my time. I think, can you look on there and see when I was supposed to finish the introduction? 11:30. 11:30. Okay. Okay. So I'm good for a little bit. So I'm going to go through these fairly quickly. I apologize, a little rapid. And again, for those of you seen it, it's no big deal. But for those who knew, I'll just bear with it. But what we're trying to do is we're trying to, basically with V2, we're trying to get model-based approach adopted using SysML v2. And so we want to increase adoption. We had pretty good adoption with V1, but there's a lot of opportunity for much wider scale adoption. We think we have the opportunity to achieve that with V2 and do a better job of modeling and by providing this language. And what is this language? It's more precise and it's more expressive relative to SysML v1 by a long shot. It is more consistent. It's more regular language than V1 by a ton. It's much more interoperable than V1 by a ton. It's usable by both the people who develop the models and the people viewing the models. That I will have to say, we'll have to see, because we don't have enough evidence of that one yet. I believe it is, but that's not based on a lot of fact yet. But hopefully we will find primarily through a couple of aspects of the language that it will be a much easier language to understand and learn and the like. It's very extensible. We had stereotypes in V1. We have some kind of a similar mechanism in V2, but it's actually much more robust. And the last item is it's really important that we have a migration path that Daniel talked about earlier today. We can't throw away our V1 models. We need a place to bring them. So we've addressed that with V2, or at least, attempted to address that in a major way. So the key elements of V2, we ended up, V1 was based on UML and the UML meta model. Well, UML, we didn't feel we could do what we needed to do with UML as the base meta model. So we actually started over. That's why 7.25 years later, we're standing here, because we did a new meta model, but we didn't throw away UML. We leveraged a lot of the concepts that were in UML, but it's this model was designed for system modeling. It's grounded in a formal semantics. It's just a much improved foundation. We have the ability for very robust visualizations. We have a very robust, if you will, view and viewpoint mechanism that allows vendors to really do a lot. And there's discussion right now about diagrams, interchange standards and things like that. So there's a lot to talk about there over time. We won't talk about it today, but I do want to point out one aspect. And that's whereas SysML v1 was a graph, you use diagrams, you use tables, lots of tables. In v2, I assume most of you know, there's also a textual syntax in addition to the graphical syntax. And I'm going to show you that in a moment here. And then finally, the third key element, excuse me, is the standardized API. We didn't have that. Every tool had an API. None of them were standard. They all had varying degrees of documentation. Now we have a standard API such that any other modeling tool or software application can interface with or interoperate with the SysML v2 modeling tool. So these are the huge aspects. Architecture-wise, this is Ed's slide. Ed's, by the way, sitting, I saw him here. There he is. He's the language architect, and he co-led the SysML v2 submission team. He and I did, but he's the language architect behind all of this. And I'm not going to go through it. We don't have time, but what you see, the important takeaway here is that the kernel modeling language is actually a separate language, and it provides the foundation for the upper layer, which is SysML. And this 7.25 years, we developed, in effect, two languages, kernel and SysML, but it was all driven based on system modeling requirements. But in order to do that, we built this foundation that SysML can sit on. By the way, so can other modeling languages. So we have, that offers a lot of opportunity for the future. Maybe Ed will comment on that in his presentation. Excuse me, as far as the basic language capabilities, this slide looks similar to what we would call in v1, the 4 pillars slide. Some of you are probably familiar with that. It looks similar. There's a lot of differences, particularly one level down from what you're looking at here. But right off the bat, for example, the behavior and the structure are very nicely integrated. The different structural aspects like actions and states are highly integrated. They're more precise. You just find it to be a different driving experience, if you will, than what you've had with v1. We have things like analysis cases that more or less take the place of parametrics. We have very robust verification cases and that view and viewpoint mechanism. We have really interesting requirements that can be more formally specified. So there's a lot of stuff that's under the hood here. So let me just, I have this one more slide. I always do this because it's really important. There's a fundamental reuse pattern that SysML v2 incorporates. And we refer to it as the definition and usage pattern. It's a very simple concept. We talked about it with v1, but it's formally part of our language in v2. So we have, pardon me, we have the concept of a definition element where you define things once and a usage element where you use it many times. So you define something once and use it a bunch of times. The important thing here is that this applies to virtually everything in the language, all parts, actions, requirements, interfaces, et cetera, et cetera, et cetera. So you go down the whole language, they have this common pattern of definition and usage. And that is huge towards, number one, just learning the language. But number two, the pattern itself is very robust. It's very powerful pattern. You can specialize and decompose, whether it's actions, parts, requirements, or interfaces, or whatever it is. You do it in the very same way. And it's really quite nice. So just to give you a flavor, again, if you compare v1 and v2, and you look on the right, you see v1 terminology, and on the left, you see the corresponding v2 terminology. What you'll notice is, like, for example, part, property, and block for SysML v1, that's replaced with v2 with part and part def. Part is the usage element. Part def is the definition element. And then if you go down that column on the left and you compare the concepts, you'll see it's just a regular pattern. Part def, port def, action def, etc. So you learn this pattern and now you're already well into learning the language. Just understanding this. And these are the base concepts. There are many others, but this is just a subset to give you a sense. And you contrast that with on the right, where we had a lot of different vernacular, and it really wasn't the same pattern. They were different patterns, different terms, but it's very clean now. It's a nice modeling experience. I'm going to just show you this example real quickly. And I'm trying to keep track of time here. Probably too small to see it, but this is a vehicle part. It says, the keyword at the top says, on the next slide, I'm going to blow it up a little bit, but just kind of go along with it. There's a vehicle, there's an attributes compartment, and there's a mass. And that mass is I think it says dry, I can't even see it here, so you can't see it, but it's probably dry mass plus I can't see it. Okay, but at any rate, it's an expression, a simple expression, just a simple sum. But SysML v2, that's using the textual syntax of SysML v2. And we have a very rich expression language, which is now parsable and interpretable, back to Daniel's point about getting, computer interpretable standards. So this is completely interpretable by your modeling tool, and then can be executed by an appropriate solver. Now that happens to be a trivial example, but it can get very sophisticated. We have here, you see some actions that the vehicle performs. And again, it's unbelievable, generate torque and amplify torque. It's just a simple little functionality to show the vehicle is going to perform that top level action called provide power. And provide power includes those two nested actions, generate torque and amplify torque. And then here are the parts of the vehicle. And again, just showing a small subset, but here's the engine and the transmission. And the engine and transmission each have an attribute for mass, and they perform some function that's related, that corresponds to or refers to the functions, the actions within that provide power. So for example, the engine generates the torque, and the transmission amplifies the torque. Again, real trivial example, but you start to get the sense. And then what you're seeing on the right is the textual syntax. I know you can't read it. Again, I'll blow it up on the next slide. But you can see it's the corresponding textual syntax. And then here you see a states, and you see the vehicle has an on and off state. And in the on state, it provides power. Well, the provide power is that action right there. So in the on state, it's doing that provide power. And then there's some transitions, and those transitions can be, you can use the textual notation to formally express what those transitions are in very clear terms, clear and unambiguous terms. So this is just a piece of it. And then here's an example of a specification. This is the vehicle specification. I've shown one requirement in it. You typically look at this in a tabular view, but I'm showing it graphically. So here's a mass requirement with a formal constraint that says the mass must be less than some value. And that can be checked against an actual value. So you can run a check against this requirement and see whether you pass it or fail it. And contrast that with what you would do with a text requirement, which you can't do that. So this gives you a formal way to specify the requirement. In addition to your text statement, you can actually put in a formal constraint expression that gets evaluated. In this case, we've allocated that mass requirement to the mass of the vehicle. That mass is shown graphically as a node down there. It's one and the same as the mass up top. I just wanted to show it as a node so you could see the relationship. And then here's a verification case, and it's verifying this requirement. the mass. It's a mass test that's verifying the mass requirement. So what's the takeaway here? It's kind of classic systems engineering. You're seeing a structural view. You're seeing some behavior in both actions and states. You're seeing some properties of the system, in this case just mass, but you can imagine all kinds of properties. You're seeing a requirement applied, allocated to this one of a feature of this vehicle. You're seeing a verification that verifies that requirement. So this is sort of the core part of the language, just for starters, that you can learn quickly and kind of come up to speed pretty quickly and do this kind of modeling. And there's a ton of additional capability beyond what you're seeing here, but this gives you the core foundation to start with. And if you have this, you can go onto a project. If you can do this well, you can go onto a project and add value right away. Now let's blow this up a little, just the top portion. Let's blow it up a little bit on the next slide. Hope it's a little bigger. So I'm just showing you the top part. I'm showing you the provide power action. All I wanted to do here is just blow up the textual syntax right next to it. This is the corresponding textual syntax corresponding to the graphical. So you see the part, for example, you see this is the part vehicle, and so is this. This is the mass, and this is the mass. This is the perform action called provide power. This is the perform provide power. Here's the states, vehicle states, vehicle states. You can see there's curly brackets and there's 2 stars in there. That means there's more content that you can't see. It's collapsed. Here's the part engine, and you can see its attribute, its port, its action corresponds to what's in here. Similarly with the transmission, here's this action, provide power down here with 2 nested actions and a flow. So that's what you're seeing down here. So when I say provide power, I'm actually referring to this. So this provide power here is referring to this provide power. And so your takeaway here is that the textual syntax and the graphical syntax are just 2 different renderings of the same underlying model. And that's what you're looking. So you can, in an appropriate tool, some tools are supporting just textual, some emphasize graphical, some have both. But you'll find that when you have both, it's a really nice experience. I'm not a software developer, but I actually love using the text in conjunction with the graphics personally. It's just really nice. And you find reasons to use the combination to get system understanding and the like. So I just wanted to show one more, and let me check my time because I got to make sure I don't. Okay. I just pulled this example off of our SysML v2 release group, and it's a snippet of a model, and this is the person who wrote it, Vinay Palia. I don't know him, but I just pulled it off because I was kind of intrigued by the example. And you can say, he says, I'm trying to build a simple model of a PWR nuclear power plant. That's a pressurized water reactor. And you can see some description. And he says, I've created many of the elements, hydrogen, helium, boron, and et cetera, uranium, 235, et cetera, plutonium. At any rate, he's got all kinds of stuff there, basically building the periodic table. He was just asking for advice on our release group of how do I create that periodic table with a proper array. And but what you see here, if you can make it out, is there's part defs for, again, I can't read it here or even on here, but there's neutrons and protons and electrons and atoms with mass, particle mass values and all that stuff. And it goes on from there. This is a little snippet from his model. Talk about fundamentals. I like this. This is a really nice start. Why don't we can start modeling here. This is a good place to start with an electron. Okay, so I thought that was neat. Anybody else think that's neat, or am I just me? Okay, good. All right. So with that, I just wanted to say, with respect to the API, this is a really important part. You know, we talk about the language, but the language is complemented by the API, thanks to Manas. Where's Manas? He's somewhere. All right. Maybe it's not. Anyway, what you're seeing here is just a depiction of the SysML v2 model repository. So you got all this data in the repository. And the idea is you build applications that talk to the repository and get data out, put data in, modify data, do all this, manage the data. And these are some examples. There's an analysis tool that's pulling data out. There's a geometry tool that's actually pulling geometry out of the SysML v2 model. Thanks to Hans Peter, who's sitting right there. There's Tom Sawyer, which is one of the tool vendors out there. This is they use the API to pull data out and visualize. You can go to their booth. Intercax, you'll hear from Manas. They pull data out and manage it, so manage the digital thread. These are just a subset of the vast number of applications that we can do to support Daniel's vision of the interoperable digital engineering thread, or as he said, the tapestry of threads. Thanks, I'm sure, to Chris. Anyway, okay, so that's a really important part of this, and you'll hear a bit more about that when Manas speaks in a few minutes. So comparing the two, and okay. I'm just going to hit just the top bullets here. I do think, personally, it's simpler to learn and use. Not to say you're going to learn the whole language quickly, but you're going to learn a base part of the language quickly that you can do stuff with. That's really the key. I think we can ramp up quickly to get a base capability, and we'll have some experience with that shortly. So that's real important, and the consistent terminology is really key to that. But consistent patterns and terminology and many other things I don't have time to go into. It's very much more precise. And you see that instantly when you're using it. You can see from the textual notation, but it's obvious. I mean, that's done. It's more expressive. We have new concepts. You'll hear from Tim a little later today. He's got a presentation on variant modeling. And you just get a sense, oh, you can do that with V2. You know, it's one example, but there's tons of things that are in the language, which obviously we don't have time to go through. You know, lots of capability. And then it's more extensible and it's more interoperable, primarily due to that API and some other aspects. So this is how we contrast it. I want to say very quickly, and again, I'm rushing through this, but I want to just say a few words about this community. And I want to note that, first of all, we have a system modeling community through the OMG. That's really neat. And these are some of the working groups within it. And they're all working hard and they're interesting. And you ought to, if you're not familiar with it, you're interested in this, this is the place you can start and go to. You can go to the SMC. There's a URL at the top. This will get posted. But you can go to the OMG page and join. You can join as an organization or you can join as an individual. That's not the same as the OMG standards part of the organization, where it's just corporate or organizations that join. Lots of great work here. I wish I had time to go through each one of these, or I wish the leads had time to go through each one of these. We don't have that, unfortunately, for today. A lot of them are here, though, so you can speak to them. We have, I mentioned this community, we have this public repository that we're going to build on. It's got a lot of data. It's just a start. We're going to explode, hopefully, the model repositories, so we become this shared environment for sharing models and data across our community. And if you're interested in joining, there's a release group. That's where you go to. You can just go to that URL and sign up and become a part of it. And for example, the one with the periodic table, that was on that release group. I did want to reinforce what Steve said about NCOSI's role. We now have an MOU in place. We've had it in the past, but this last year, we put in place a very encompassing memorandum of understanding between OMG and NCOSI to encourage collaboration. We've actually been doing a lot, but we could do more and do it more formally and, you know, things like that. And, you know, right now we have been for years, a lot of NCOSE people come to OMG events. OMG people go to NCOSE events. We participate in chapters, working groups, the international workshop, the symposium, all that stuff. We're very active. We often share where we're at, you know, so there's a lot going on there. And these are some of the modeling standards that NCOSE has been actively engaged in helping to support, and others. But I picked out the ones that I'm particularly familiar with. I got to give a shout out to these vendors. They've been working like crazy. These are the vendors that showed up at the international workshop in Spain last month. And they each had a booth and they all participated and gave their roadmap of where they are and where they're headed. And that URL right down there is on the MBSE wiki. You can go there and see a video of their roadmaps. It's very good. So if you're interested, again, this will be posted, but note the vendor support slide and that URL, or you just go to the MBSE wiki. You should be able to find it. If not, come to me. But at any rate, these vendors were there, and then today we have some additional 3 vendors that I don't believe were formally at the IW, Qualtech, Cisgit, Model Driven Solutions. But all the ones with the green asterisks actually have booths here today. So again, take a look. I'm not a sales guy. I'm not doing sales. I just think it's real important to see what's out there. Okay, I want Vince to come up. You got 5 minutes, Vince, and then we turn it over to Ed, and he is going to talk. So if you just introduce yourself real quick and just use that.
Yeah, thank you very much. So my name is Vince, whatever you prefer. Monar, I'm an associate professor from Hungary. So I'm coming from academia, and I'm still here working with all the guys from industry, all the guys from academia, trying to build a bridge. And I was really happy to have the opportunity to talk to you about the formal methods working group, because I think it's a real good example of this kind of collaboration, which is one of the strong points of the whole systems modeling community. It brings together people from different fields, so we can work together and realize things which are now possible because of SysML v2. So the formal methods working group, every working group has a charter in the SMC, so you can just browse the mission of each working group. Ours is to facilitate the application of formal methods on kernel and SysML v2 models by sharing experience in the integration of formal methods tools, defining precise mappings to formal languages, and providing feedback to other working groups. And we also have the mission of extending the language with different capabilities, for example, temporal logics as a library, because now we can do that. And perhaps transformation rules that could be standardized at some point. So what is formal methods? Formal methods is basically the application of mathematics and different theories to analyze different properties of system models in this case. It can be any kind of model, it can be software. If you paid attention, there is a kind of a revolution now led by Amazon and TLA+. People are discovering that you can do model checking, you can do formal verification, and that can increase the quality of your products greatly because you can catch errors early. Now, of course, I said mathematics, so this smells like academia, right? And that's right. We have like over 50 years of research here, and it's barely applied. It's not very accessible, and that's a problem. You need to be highly trained to use these. It's very complex. You can shoot yourself in the leg like a gazillion ways. So it's very hard to apply formal methods. And this is what we are trying to do here. Sandy said multiple times that SysML v2 is much more precise than v1. I can actually confirm that. It's precise enough to apply formal methods directly on SysML v2 models so that you don't have to look at the nasty bits anymore. You don't have to learn formal languages. You don't have to create the inputs for these tools. You just write your SysML v2 model and everything should happen auto-magically, right? So because I have only 5 minutes and I already used 2, I really want to show you like some of the results that we had in the past year. We started last February with an event called Formal Methods February. Perhaps some of you attended, where we showed 5 tools basically. So that's where we started, and it gradually grew into a very nice community with with researchers, tool vendors, practitioners, so a very diverse community. And one of the results is actually published in a paper which is submitted, and an earlier version is already available. I'm not sure I will, yes, I can show you this image. You should not look into the details, but what I want to show you is that in the middle, you have SysML models, and there is this whole ecosystem of other tools processing your models under the hood invisibly. So you don't have to deal with these boxes down here, which are all different solvers, model checkers, analysis tools. They are very hard to use. They are also quite popular among the people who actually know how to use them, but you don't need to do that anymore. And the colors you see here are all different kinds of analysis techniques. It's not only verification of requirements, it's also safety analysis, architecture exploration, behavior exploration, test generation, for example. So the goal of this working group inside the community is to bring all this functionality to you under the hood, hidden, with the cooperation of researchers and industrial practitioners together. I think that's what I could squeeze into 5 minutes. Thank you.
Thank you, Vince. Again, I just wanted to show just a quick sampling of one of the working groups, and this will happen to be this one. But there's like 14 working groups, all really making outstanding progress, all very interesting, verification and this and that, real time back there with Gene and Jerome, if he's in the room. They just got their MOU signed with SAE, so congratulations. So that's a really big move. So you probably don't know what you're clapping for, but it's great. So, but at any rate, it's lots of good stuff. So please encourage you to participate. Okay. So let me just finish up with this last slide and just note that, you know, I think V2 is clearly addressing many of the limitations of V1. We'll see, you know, as it gets out into practice and we're using it, but it's not a foregone conclusion. You know, good modeling language, good modeling tools, not enough. We need good systems engineering. Remember, that's the foundation, good system engineering, creating, you know, good system models with good language, good tools. You need the training, you need to be disciplined, you need to be rigorous. That's the way we'll get there. So it's, you know, and you'll find is you're a lot more accountable with this modeling language than even we were. You know, you're unaccountable when you're working with a document, right? Somebody reviews it, sits on a shelf, and that's it. You put it in a model, you start to be accountable. You put it in this kind of model, you're starting to get really accountable. And that's really important because our work will get visibility in terms of, is this good? At least is it a good model? And you can start answering that question. I've said all this. I'm not going to repeat it because of time, but you know, our plans, our final adoption, like I said, hopefully June of this year, published in September. That's our target. We're there or darn close. And we're going to continue to evolve this capability. This is a kind of, I mean, I view this sort of as a kickoff. Should take a picture from here. I can see all you. Okay. And I believe that you should, and you'll hear more about this later, if you're interested, and the fact that you're here indicates some level of interest. Take it back to your organizations and take some of the guidance you get from that wiki that Daniel referred to up front, and from what Chris and Emma will talk about a little later today. Take the guidance and learn from it and move out on your transition plans. You don't have to do everything now. It's an incremental process. Start out with a strategy and a plan. Makes sense for you. And there's a lot of guidance to help you with that. And that's kind of where we are. So with that, thanks.